Namaskar, I'm Ashok Vyas, and this special edition of Wild takes us to the space, and the space which is unexplored is always exciting and fascinating. And that fascination pulled Vishnu Sridhar, as we have heard about him, a man from Queens, but I would say he's man with Indian roots, and that Indian American young man who newspapers are saying 27 years old is the lead systems engineer for the Supercam on the Mars 2020 Rover Perseverance. And this is distinct honor and pleasure for me to welcome Vishnu. Namaste.
Hi, thanks so much for having me.
So let us go to your first look at the space, and you started imagining. I believe, be it an artist or a scientist, imagination plays an important role. Talk to me about your blossoming of this imaginary faculty of imagination.
Yeah, I mean, creativity and imagination is why we have all this exploration, and it starts from the curiosity. Um, for me, my passion for aerospace and aviation started right before I started high school. And that's why I pursued an aviation public high school in New York City, and eventually went to study aerospace engineering, which led to a position at JPL, NASA.
When
So
you
really
say
excited to be here.
absolutely. I would still stay with you before you joined NASA because that journey you made it so simple for us to see must have had its own challenges and some questions whether I'll be able to do it or not. Or so let us learn a little bit more about your formulating years, studying here in Queens, and then figuring out about your career or how to uh, get to the door step uh, which would make you a family at NASA?
Yeah. So since I was young, I was really interested in science and technology, and I really enjoyed watching like Carl Sagan's Cosmos TV show, and also learning about different engineering things like my grandfather did and things like that. That really initially sparked my interest to pursue engineering. And also living in Queens, you're in the middle of two giant airports, and I see airplanes flying all the time. And that really made me curious to learn how airplanes work and fly. And that was really the moment I started looking into aerospace engineering and thinking about pursuing that at the time.
And when you consider your career and you start studying, then what you would say acted as your role model at that time? And as you were mentioning about Carl Sagan's Cosmos, and any personality whose name is known to have made a mark in the field of space science, who sort of inspired you?
Yeah, I would say definitely Carl Sagan, and the inspiration coming from exploring the unknown and not only thinking about what's happening on Earth, but also trying to understand and answer fundamental questions, and where we are in the universe, and exploring that, like looking at the big picture, and reading about those things are made me really curious.
Talking about curiosity and talking about distraction in the digital age, um, how would you describe as a student what helped you stay focused? And sometimes kids have some dreams and parents have something else in mind for them. On that front, was it always clear, or there was something that needed to be sorted out?
Yeah, absolutely. I mean, when I was growing up, social media was just starting, and it was just a new thing that was becoming more and more popular. And nowadays, social media is the thing, and people are learning so much from social media. And I think it's all providing right directions. So, like kids growing up now, young aspiring scientists or engineers or even artists or anything you might be interested in, still following science and technology news on social media could keep you aware of what's happening and how our future is going to be shaped. So I think social media is really a good thing, but it depends on which direction you're following and what you want to look for.
So, I'm still staying with you here while Vishnu Sridhar is dreaming big or figuring out ways to move ahead in his life. What used to be your typical breakup of day? Were you considered very much focusing only on studies, or there were other interests which you were pursuing?
No, not at all. Like growing up, I was not only doing my academic coursework, but I also was reading science and technology news on the internet. I was really into tennis, so I was following that news. And photography is another thing I really enjoyed, and little projects I like to do. So it's really you should just follow and do what you really enjoy and like, and not only follow academic, although that's key and important to where you want to go, which is a tool that you need, but also pursuing your other interests and hobbies. It's a key thing to have to keep yourself busy.
So I heard from your father that you always wanted to become a aerospace scientist, and there was something in your mind which was pulling you towards the place where you are right now. Would you say this is something inborn, or how that passion becomes a part of one's being? If you care to say something about that.
Yeah, the reason I really started aerospace engineering is because Um, so if you imagine like 100 years ago, or in the modern history, we have airplane technology and we are able to go to different parts of the world and explore different things. And that wasn't the case a century ago. And similarly, now with the technologies we're having with NASA and space missions, it's really making humans explore worlds beyond our own. And that way we are curious naturally as humans, and I had a similar curiosity and I wanted to explore what's out there, and applying to JPL and NASA missions like was the right thing for me, because every day Mars exploration, we send the rover, we're exploring a new territory that we've never been, and that's really exciting to me.
So, coming towards this exciting moment, and also going back with you to the days when you probably were observing your father performing as a dancer, did you ever felt taking interest in classical Indian dance form, or the way your mother was pursuing her interest? How do you look at the impressions that you got from them?
Yeah, that I mean, it's a well-rounded experience, I would say. Like my parents were really into classical music, dance. I was into science and technology, and I think it's a good balance to have in every field. One needs a little bit of everything and have an eclectic taste, and that definitely gave me a good distraction on times when you need to not think about science and technology. I can go and explore the Indian classical music and dance forms, and also the rich heritage that comes behind it, and learn about the history.
And now, since we both share that Indian background, Indian cultural side, and astrology is also considered as a kind of science, or maybe not, but there are many practicing astrologers even in America. And then the way you hear about the impact of different planets on the way events unfold in human life. As a scientist, I think you may not subscribe to those ideas, or how you look at this overlapping space of knowledge with different approach.
Yeah, I can't comment too much on that, but I can tell that like there's a famous quote that I've heard many times, is with great claims comes great evidence. So if you need to make a big claim, you need a big evidence and proof. And with as an engineer and a scientist, we always look for compelling evidence, and that's what we're trying to do with our Mars missions, to see if we have compelling evidence with the instruments we have to answer fundamental questions and things like that. So that's basically my personal opinion on
Very good.
things.
So now we go to NASA with you, and before we come to the present major achievement, how was it initially for you to learn your teammates, and anything that you want to share about how NASA made you feel in terms of helping you kindle your curiosity, the fascination, and the structure which help you pursue your passion?
Yeah. I personally think that NASA and JPL is a very inclusive community. I mean, there are well experienced people on my team who have basically been the pioneers of space technology in terms of robotic exploration, and they built the first spacecrafts we sent to Mars for like Pathfinder and the Opportunity Rover and things like that. And as a young engineer starting to work at JPL, learning from them, I was given the opportunity to be in teams and make big decisions that would impact the mission. And I was given that opportunity and wasn't turned away as a young engineer. And I think that's something JPL values a lot, and I gained a lot from.
And let's talk about this rover perseverance, and when this all started, and at what point you became a part of it, and what has been your role. Has there been some changes in the role that you have played in this whole project?
Yeah, so the Mars 2020 mission, or Perseverance, really kickstarted about 6, 7 years ago. So that's when the scientists around the country and around the world came up with the proposal saying that these are the instrument suites we have, and we want to send it to Mars, to a particular landing site, so that we can answer some of the fundamental questions like, was there ever life on Mars? Can we find any biosignatures? So after that was initially approved by NASA, JPL started building the rover and the instruments and collaborating with our international partners in France, Norway, Spain, and etc. And my job really started about 3-ish years ago when Supercam really started going into the design and manufacturing phase. So I was at JPL in charge of integrating the Supercam into the Perseverance rover and making sure that all the testing in terms of thermal, all the electronics and flight software behaviors work as expected. So over the past years, I've been taking Supercam from integration, testing phase, putting it in a thermal chamber, making sure everything works nominally, and the launch that we had last year from Florida. And after the launch, Supercam and Perseverance is on its journey to Mars, and we need to do a series of testing and things like that. So I was involved in that. And of course, now it landed safely last week.
The Mars 2020 rover will initiate a long sought after mission of returning Martian rocks and soil to the Earth for further study. The Mars sample return mission is a high priority not only for the scientific knowledge it will provide, but also the opportunity it presents to tackle a difficult technological challenge. Remember, Mars 2020 is going to have the first Mars helicopter. The Mars sample return will include the first ever rocket launched from another planet.
There are more testing and things to come before we really start the science operations.
So your smile tells me a lot about how this made you feel, and walking with you to understand a little bit more. When you say Supercam, of course, it has some additional capabilities of not just taking pictures, and there is much more. So, tell me why it is called Supercam, and what is it that it can do?
Yeah, Supercam is basically a really complex and powerful suite of instruments where it uses lasers to detect the elemental composition and mineralogy of a target. And it can do that from a distance. That's why it's called a remote science instrument. So the rover can look at a target anywhere from 2 meters distant to up to 7 meters, and it can fire lasers on that rock. And then the light coming out of that is read by the spectrometers of Supercam, which can use scientists and engineers to determine what the rock composition is made out of. And we also have other things in Supercam, like a color microscopic camera. We have a microphone, so we can hear how Martian environment sounds, but also the laser pits that we can hear, where we can interpolate what that means. And it has like infrared spectrometer and things like that that really is used to study rocks and soil on Mars.
All these terms are very impressive, and when as a layman you try to process them, you may not be able to reproduce all of them, but you get a gist of what he's saying, and I also got part of it, Vishnu. Just to make it more clear, typically when we talk about camera, the idea is that it is taking pictures, but here it is a super cam, so it is not just taking high resolution pictures. It also have the capacity of interacting with the rocks in a way that it is gathering more information and processing it to come up with results about its chemical composition, etc. So this is mind boggling. It is like, as of course it is more like a science fiction, science fiction. So it's like you see somebody and then you absorb everything that is there. So what goes in making a super cam, and anything where you have been closely involved, because some parts came from France also, am I right?
Yeah, that's correct. So the Supercam has two big components. It has the mast-mounted instrument, where we see on the top of the Perseverance rover, that's where the laser comes out of. That's where we have the microphone and things like that. So it has its own flight software running. And that part was manufactured with our colleagues at the French Space Agency. And it has another component inside the rover body called the body unit of the Supercam. And that one, it basically has 3 spectrometers, and it also has a flight software running inside that communicates with the mast part of Supercam. And 2 of them synchronously work together. And the body unit was designed and built at our colleagues at the Los Alamos National Lab in New Mexico. And both of them together work together, and we communicate with the rover software. So you can see it's a very complex instrument. You have mast-mounted software running, firing lasers. You have the body unit with the spectrometers. And you also have a calibration target in the back of the rover, which was from our colleagues in Spain, from their space agency. And that's used basically for calibration. So Supercam fires lasers at the rocks and soil around us on Mars, but we also want to calibrate how that works. So we look at the rover, and on the calibration target, we fire the laser to basically calibrate our instrument. So all of them work synchronously together and produce science. And JPO interface, which is me leading that effort, is to make sure that the whole instrument and component work together with the rover and everything is nominal so we can collect science.
So when you say we can collect science, you have some specific thing in your mind, but just for our viewers and for me also, what is the main objective? What are the top ideas with which this rover Perseverance has landed at Mars? One of them I was fascinated is related to figuring out whether there was any life existing at Mars, things like that. So talk to me about more and this, and also it is just a curiosity as a scientist is one side, and then there is a larger question which generally in the world of utility that we have, what are the larger implications down the line for nations, for human beings?
Yeah, absolutely. Perseverance mission, the main goal of Mars 2020 is to collect samples. So what that means is that the rover has a sample caching system where it has a small arm that comes out, collects a sample, puts it in a test tube, and leaves it. And then the rover drives away and collects more samples. And the reason we want to collect sample is we want to bring it back to Earth one day so the future generation of scientists, So kids who are now in middle school, high school, when they become scientists in a decade or two, they're going to be studying the samples we're going to be bringing back from Mars that Perseverance is going to collect. And for collecting that sample, we need to make sure that we bring a compelling evidence, we bring a good sample that we can study for decades to come. And for that, we need like a suite of instruments that basically looks for biosignatures. And what I mean by biosignatures is that the rock and soil that we look at and analyze on the surface of Mars in the landing site we landed in should show that there was some hints of organics or some elemental composition and mineralogy that hints that one day back in the past, billions of years ago, there could have been microbial life on Mars. So that's what we're trying to do. With the main goal of the mission is to use our instruments to look for a sample with biosignatures collected in a test tube. So one day we can bring it back to Earth to study more. And to answer your last question, what this means for future of humanity or the human race. So Perseverance also has other piece of technologies that basically help us determine how we can have humans on Mars one day for human space exploration. And that's why we have the MOXIE instrument. It's an acronym. And it basically produces oxygen on the surface of Mars using the Martian atmosphere. So that's going to be a huge leap for us, because if MOXIE works fine and if it can produce oxygen, then one day when humans go to Mars and land on the surface, they can produce oxygen and use that for survival. So that's going to be a key technology demonstration that Perseverance is doing.
That's very, very impressive and incredible information and insight, and tells us about the proactive approach as well as farsightedness, and I would also say compassion with which scientists approach their expedition. And then we look in contrast what is happening around us. But leaving that part aside for some other day, Vishnu, there is one buddy with rovers, that is ingenuity. Ingenuity.
Mm-hmm.
And
Yeah.
Tell me more about that.
Yeah, I mean, if anything, I think engineers at JPL are very, very excited about Ingenuity. It's a buddy that's going with Perseverance rover, and it's a small helicopter, a rotorcraft that we're going to attempt to fly on Mars in the upcoming month or so. And it's going to be the first air-powered vehicle on another planet outside Earth. So this is a huge path forward in terms of technology development and also demonstration. And this goes back into the history, like when we see, like, for example, in the late 90s, when JPL NASA sent the Pathfinder mission, it was a little lander that landed on Mars and looked around and collected science. But we also sent a small microwave-sized rover called Sojourner. And that was similar to Ingenuity, the first time we were sending a rover to Mars and trying to see how that's going to operate and how that's going to work out. And from what we learned with the Sojourner rover in the late 90s, we sent the Mars exploration rovers in the early 2000s. And they were like the first class of Martian rovers that roved around Mars, collected science, and sent pictures back to Earth. And then in 2012 timeframe, we sent a much larger rover from what we learned from Sojourner timeframe still, and Curiosity. And that also roved around Mars, collected science. And now Perseverance is not only we're sending a rover, but we're also sending like I said, a rotorcraft with it, so that we can demonstrate that we can fly, like we can fly an air-powered vehicle on Mars. So that basically tells us that if it works all fine, and if we know everything is the science and the engineering works, then we can send more air-powered vehicles to other planets to explore. So now we just don't need to drive a vehicle on Mars. We can actually fly, and that would just change the way we explore another planet. So really excited to see how Ingenuity is going to perform.
I'm very, very excited to hear your experience as well as all that we have as human race achieved already. There are talks about future inhabitation of other planets, and I don't know much about that. Yet there are people who are booking some places, and those kind of news also come. Coming from NASA, when you are looking at space, which of course stands for vastness. We go beyond the boundaries of nation also to some extent. Yet there are some special, I would say, uh, focused way of making sure that scientists continue to work and their work is not interrupted. Keeping this idea in mind, talk to me about how American system is geared to make sure that this scientific temperament and this journey with passion and curiosity and exploration is sustained. Anything that you have experienced or you may want to fill in on this?
Yeah, I mean that's all definitely true. Like JPL, NASA, the history has proven we have sent spacecrafts to different planets. We have explored the surface of Mars, and that's just the nature of the human mind. We want to explore the unknown. We are curious. We want to see what's out there, and I'm really glad and fortunate to be part of that mission with Perseverance.
And the name of this mission is Perseverance!
So like last year, 2020 with the pandemic, it really showed us how what's affected by the world and nature of events that happening is affecting our work and what we do. And as many know that we can't send a spacecraft to Mars whenever we want. It's a once in a decade thing. And there's only a short amount of window where we can launch to Mars, and that's like a month time frame. And that time frame was last year in the summer when we launched Perseverance. And if we miss that boat, then we have to wait 2 years before we can send another spacecraft to Mars. So with the pandemic happening and everything, I think the Perseverance rover got the perfect name, Perseverance, because we really persevered through the pandemic, and we learned how to work remotely. It was a paradigm shift. We adapted to doing engineering practices and discussing anomalies and resolutions virtually from our apartment and homes. And I think the JPL community and the NASA community really helped us achieve that in terms of like the IT technology we get, and in terms of the support we get from not only the engineers, but also the extended team. So all of that at the end worked really well together, and synchronously, we were successfully able to launch and land on Mars during a pandemic.
Absolutely. Once again, I want to congratulate, as well express my joy and happiness on the successful launch rover Perseverance 2020. And this perseverance word is relevant for one and all at whatever stage of life we are. If we do not sustain our momentum with our passion to pursue whatever we are, then that would leave us somewhere halfway. So, but that was Vishnu Sridhar, very kind and very generous to be sharing all the details about his journey. And once again, I want to express my joy and compliment, as well as convey my congratulations to you, Vishnu. May you continue to move ahead and realize your dreams. Thank you. Namaste.
Thank you so much.